my name is Samaritan Pathway. We're Tower Engineering, and we're pleased to present to you our presentation on the Hazlet Village Square redevelopment. My name is Laura Anderson. I'm a project manager for the team.
I'm Summer Alcataro. I'm the environmental specialist.
I'm Eric Warman. I did the water resources.
I'm Stephen Kegman. I'm the geotechnical specialist.
Nick Tower, the structural engineer.
I'm James Beal, the transportation specialist.
And Kuczynski, the pavement specialist.
Alright, so to start, we have our preliminary design for you today for the Hazlet Village Square redevelopment. We are involved as Tower Engineering, who've been hired, and then the owners and developers are Capstone Collegiate Investors, and then the site is located in the Meridian Charter Township. So, what is necessary and what has been wanted for the project site development is they wanted a brewery, a restaurant, apartment complex, a grocery, and then expansion of the already existing Samaritan Pathway. And then our primary goals and what we wanted to really focus on in the redevelopment, while getting what was necessary, was walkability, maximizing the green space on site, having a marketable development, and then we had sustainability also at the forefront. So Capstone Collegiate Investors, their primary goal was to have the site be marketable to bring business and to meet the needs of the future and current demographic, while the goals of Meridian Township were focused on the walkability, green space, and sustainability. So this is where the project site is located in Meridian Township. It's just south of Hazlet Road and west of Marsh Road. It's south of Lake Lansing. There's a middle school located just east of the site also, and then there's a railroad that runs just south of the site. And then this is just a zoomed in image of the site that you can see. It's about 29 acres. And I'd also like to note that you can see the bank in the east corner has just recently been reconstructed and redone, and so we're going to talk about the pavement rehabilitation that we're just going to be doing on that section. So these are currently the existing conditions of the site in regards to structures. So you can see that the red indicates the suites that are currently vacant. So we have the PNC Bank, this site that's not vacant, and then these are primarily being utilized for commercial space right now. And so you can see that these are vacant, and then the majority of the suites in that site is vacant. So for other existing conditions, we have the wetlands and floodplains that you can see primarily make up the west side of the site. Okay, so this is our overall site plan for our Hazlet Village Square redevelopment. So we decided to start that we're going to leave the bank intact, and then we also decided we were going to keep these two existing buildings and this existing building. We're going to turn those into commercial retail and then an organic grocery. We decided to keep those primarily because of their proximity to Hazlet and Marsh Road. So based on their visibility and advertising purposes, those are going to be the most marketable buildings for the site. Then we decided to put the brewery on the west side of the site along with the connected restaurant. We chose this because there's going to be slightly increased truck traffic for the beer production in the brewery, and so we wanted to concentrate the added truck traffic solely behind the brewery and not have it really disrupt the rest of the flow on the site. Finally, we decided to put the apartment complex in the south part of the site. We did this because we wanted to have the noise reduction that was coming off of Hazlet and Marsh, and then we also decided to place it there because we wanted to have a direct link to our interurban pathway expansion that we'll talk about later. I also want to note that everything south of this interurban pathway has remained untouched, as it's the wetland and the natural mature trees that we wanted to also keep untouched for the site. And now I'm going to hand it off to Summer, our environmental specialist.
There are three design objectives for the environmental portion of the project. The first one is to design a water treatment plant to provide water for the brewery. The second is to design a wastewater treatment plant that treats the waste produced by the brewery to be discharged into the sewer system. And the third is to design the water mains and sewer system on the site. The overall objectives of the project include incorporating sustainable technology into the designs as well as maximizing green space and protecting the existing ecosystem. This is a diagram of the brewery process, just so everybody understands where the water comes in and what comes out. The water that goes in includes rinsing water, cleaning in place water, and brewing water. What comes out includes spent grain, shrub, and yeast. So the water on the sites can be purchased from the East Lansing Water Treatment Plant. The only water being treated by this water treatment system is for the brewery, to brew beer with. The goal of the water treatment system is to provide a low ion content water that can be remineralized to any type of beer. Nanofiltration, ion exchange, and reverse osmosis were all compared, but reverse osmosis was chosen based on sustainability, cost efficiency, and efficacy. Reverse osmosis requires both pre-treatment and post-treatment. Pre-treatment includes scaling prevention and scouring prevention. Post-treatment includes pH neutralization and dissolving the gases that are not removed by RO. The existing water supply contains chloramines that are added by the East Lansing Water Treatment Plant for disinfection purposes. This water cannot be in brewery water and has to be removed. It's typically removed by granular activated carbon. However, Tower Engineering chose UV radiation because it's highly sustainable and dissociates chloramines very effectively. This is the water treatment diagram. I'm going to walk you through it so you kind of understand each process. The water is going to come in through the existing water mains and be pumped to the UV radiation room. The chloramines are going to be dissociated. Then an anti-scalant is going to be dosed, as well as a pH adjustment to adjust the pH from about a 9.3 to a 7. It's then going to go through a cartridge filter, which will reduce the load to the RO system. It's then going to undergo reverse osmosis, where 90% of the ions are going to be removed. It's then going to flow into a stripping tower, where CO2 and H2S, the dissolved gases that are not removed by RO, are going to be removed. The pH is going to be adjusted because at that point the water is highly corrosive, and it's going to be adjusted to about a 7 again. It's then going to enter a remineralization basin, where a brewery engineer would remineralize the water to suit the brewery needs. It will then be used in the brewery. So the waste produced by the brewery has to be treated prior to its discharge into the sewer system to meet Meridian Township regulations to obtain a discharge permit. So the waste water that comes out of a brewery includes rinsing water, cleaning in place water, solid waste, and packaging water. The goals of this system is to reduce biological oxygen demand, chemical oxygen demand, and total suspended solids levels to meet these regulations to discharge into the sewer system. This requires two types of digestion. The first one is anaerobic digestion, which will remove 75 to 80% of the BOD and COD. It'll then be followed by an aerobic polishing step, removing 90% of the BOD and COD, meeting these discharge regulations. This is just a figure of the process and what comes out, but I'm going to explain that more in a second. So this is the wastewater treatment diagram. The water is going to the incoming wastewater is going to go through screens first, where the spent grain and solid waste is going to be removed. It's then going to flow into an equalization basin, where the pH will be neutralized and adjusted to suit the digester needs. The upflow anaerobic sludge blanket will then undergo anaerobic sludge blanket, where biogas will be produced, which will replace natural gas in the brewery. Sludge will also be produced. It will then undergo aerobic sequencing batch reactor, where heat will come out that will be used as heating in the brewery. The sludge from that process will flow back into the upflow anaerobic sludge blanket and be retreated. The wastewater that comes from the aerobic sequencing batch reactor will be discharged into the sewer system. So the solid waste that comes out is highly reusable. So we plan on using half of the spent grain and yeast as in exchange with local farmers for the meat for the restaurant that's attached to the brewery. The other half is going to be composted and used as fertilizer in garden plots that exist on the site that can be sold to local residents to grow on. The brewery sludge is going to be dewatered using a filter bed press, which is then going to be used in soil application for local farms. This is the water distribution system. The existing system is in red and the new system is in purple. Pretty much all that was added was connections from the buildings to the existing water mains. The restaurant and the brewery water mains are separated to ensure that the brewery always has a steady supply of water whenever it's needed in the process, as well as a steady pressure. The sewage system was also added to. The existing system is in red and the new system is in purple. The biggest connection needed was from the brewery. Now Eric is going to talk to you guys about water resources.
Okay, what's up? I'm Eric Orman. I do the water resources. My main objective for this project was to create a stormwater management system for the Hazlitt Village Square site. My main goals were to update sustainability, maximize green space, be extremely innovative, and incorporate as many new technologies as possible. So I want to start off with the topography of the site. As you can see, Marsh Road is on a hill. It's going to flow downwards towards the intersection. Hazlitt Road's going to flow westbound, and anything that lands on the site is going to flow slowly towards the detention basin. Using the topography, just the general existing sewer system, I was able to create an updated sewer system using sub-drainage basins and also peak flows. So my new system is in yellow, orange. My existing system's in red. These pipes are going to be upsized to 12 inches diameter. This pipe slope is going to change so it can meet the 3 to 10 feet per second that the Ingham County Drain Commissioner wants. And this pipe is, that's a unique one. That's going to be, we have a basement for the parking lot under the apartment complex. That's going to pump water, since it's on an upward slope. We need a sub pump at the basement. It's going to pump water upwards towards the pipe and straight into the detention basin. All we needed was a 1/4 horsepower pipe for that. My second goal was to update the detention basin. This was the original one. As you can see, it's not very sustainable. No sediment forebays, no buffer zone, no real native plants to help it bioremediate any first flush pollutants. Yeah. With the new one, I added sediment forebays, I added a buffer zone, I increased the size for demands, and yeah. So my new detention basin, its detention time for bank full is 29 hours, which is right within the Ingham County Drain Commissioner's code of 24 to 28. I also created an extended detention basin, and the outflow riser is going to be 2.5 feet off the bottom to incorporate first flush so it can permeate down to, I think it's sandy loam. I got use the soil borings to find it out. But this is what's going to separate my design from the rest. For storm sewer, I have rooftop gardens and rain barrels to collect stormwater coming off of the roof. I designed this whole thing using 1/4 horsepower pumps to get water back onto the roof after it drains off. That'll save a lot of stormwater going into the sewer system, going into the detention basin. We also use the current sewer system. That'll save a lot of time. And we also incorporate a lot of green space, which will save a lot of stormwater. For the detention basin, as I've stated before, I've added native plants, an outflow riser, sediment forebays to slow down the incoming runoff so it can settle. And I'm also using the current system so we don't have to excavate too much and keep costs low. And now I'd like to hand it over to Stefan. He's going to do the geotechnical stuff.
I'm Stefan Kegline, Geotechnical Specialist for Tower Engineering. I'm excited to present to you today the preliminary design for geotechnical works. Start off by introducing some of the main objectives for the geotechnical design, which includes estimating excavations, which includes estimating backfill, and we're also going to reuse the topsoil for landscaping purposes as a sustainable practice. Also included in some of the objectives was designing a foundation against excessive and differential settlements, as well as bearing capacity failure. The final objective was designing retaining structures and the required drainage systems for the underground parking structure. Some of the goals that were kept in mind for the design were safety, being economical, and sustainability. I have here shown a soil profile. This was translated from the borings provided by the owner. It ranges from, these are all within the building footprint, ranges from the west side of the building to the east side of the building. I want to point out the blue clay That's the problematic soil on site, which is shown here in the yellow. I also wanted to show the excavation depth. I chose 20 feet to excavate most of that soft blue clay. Also shown on this would be the 13 feet of where the bottom of the footings are located. As you can see here, some of the elevations are shown, water tables shown, and distances between the borings. Some of the soil engineering parameters that were used in the design include unit weight of soil, standard penetration number, standard penetration corrected for field conditions, standard penetration corrected for effective overburden pressure, modulus of elasticity, and angle of friction, which I'll get to in a second. This table just shows a breakdown of each soil type and the range of values that were calculated from the soil boring logs and SPT data. This is just a schematic of the excavation. One of the goals was to calculate the amount of total excavation needed. Building footprint's 285 feet by 90 feet. Some localized additional excavation of blue clay was needed below the 20 feet. As you can see, a total of around 21,000 cubic yards of excavation is going to be needed for the site. And as I pointed out on the last slide, there's going to be a 7-foot backfill of a medium sand layer. This is a schematic of the different foundation layouts that were used. A 6-foot by 5-foot exterior footing, a 4-foot by 4-foot corner footing, and a 6-foot by 6-foot interior footing. The design soils are shown here below. Again, the 7-foot sand backfill layer with an angle of friction of 36 degrees, and 6-foot glacial till layer with an angle of friction of 44 degrees. These foundations satisfy the footing thickness and frost protection requirements of the Michigan Building Code. I also want to point out directly on top of the footings is a 6-inch gravel layer with a 6-foot floor slab layer on top of that. Engineering analysis for bearing capacity, Mayer-Haas method was used. Top table shows the column that were provided by the structural engineer. Maximum and average axial loads. The bottom table shows the bearing capacity calculations for each footing type, ultimate bearing capacity calculation, as well as factor of safety. The required factor of safety for the apartment complex is around 5, and as you can see, each footing meets that requirement and actually exceeds it. Engineering analysis for settlement, Schmertmann's method was used. Settlement actually controls the design and the size of the footings. Design was based on the soils below the footing. Maximum allowable total settlement was 1 inch, and max differential settlement of 0.2 inch. Table below shows footing settlement for immediate and time-dependent settlements for each footing type. As you can see here, each settlement is within that 1 inch tolerance, and the difference between each footing is less than that 0.2 inch requirement. Engineering analysis for the retaining wall. Red King's theory of lateral earth pressure was used. Got a schematic here of the retaining structure. On the top table, I have design parameters for the retaining wall calculations, lateral earth pressures, and moments calculated from that resulting force on the wall. On the left side would be your passive pressure. The right side would be your active pressure acting on the wall. I also want to point out the drainage system within the retaining structure itself is a 4-inch diameter perforated drainage pipe surrounded by a pea-stone filter layer. Bottom table shows the factors of safety for overturning, sliding, and bearing capacity. The required factors of safety for the retaining wall is 2, and as you can see, that is met by each of those sliding, overturning, and bearing capacity. Now I'm going to hand it off to Nick Tower with structures.
Once Once again, I'm Nick Tower, and I'm the structural engineer for Tower Engineering. And as a structural engineer, my responsibility was to design a multi-unit commercial, residential apartment complex. And as Laura said before, it'll be at the southern end of the site there. And with that, I had a list of requirements for the design. First of all, I was to develop a structural layout. And using that structural layout, I was to develop an architectural layout that maximizes space within the apartment complex. From there, all the load calculation was performed, and then the loads were input into a structural analysis model for structural analysis. Once all the structural analysis was complete, the maximum loads on each members were used to do member design, and from there, a cost analysis was performed. The main objectives that I tried to meet throughout the design was to design a sustainable building that met all design codes and standards while also meeting all the requirements by the owner. Lastly, the main goal is to provide a marketable living environment for the owner to market towards the public. A number of design constraints were included by the owner and the architect. First off, the building to be constructed was a 4-story building with a underground parking garage. Next, the maximum building height was to be 65 feet above grade. The apartment complex was to be composed of a minimum number of 80 units, which are range between 1-bedroom and 4-bedroom units. Also, a requirement was there to be a minimum of 6 4-bedroom units and a minimum of 6 3-bedroom units. Also, the minimum unit area of each apartment complex is displayed. Also given by the architect was the overall plan of the structural layout. A simple rectangular footing was used as a dimension of 285 feet by 90 feet, and the building is oriented in the east-west direction. The next main focus of the design was to decide the material the building would be constructed of. My decision was to go with a steel frame building with some concrete features. The main advantage of this was the structural columns are smaller in size, which would allow for greater floor space throughout the apartment. To support the wind load in the lateral direction, brace frame configuration was used. The decision for the roof was to be a flat roof composed of a composite steel deck slab, and also the residential floors will be utilizing a composite steel deck slab with steel decking at the bottom and a approximate 3.5-inch concrete floor with wire mesh throughout. As you see here, this is the structural plan view layout. All the columns are numbered, and a maximum span of 25 feet was taken into account, and the maximum span for each bay, for the bays, is 24 feet. Here we have the structural elevation in the north-south direction. Like I said earlier, brace frame configuration was used, and chevron bracing is utilized to provide lateral stability in both directions. Similarly, the east-west elevation shows the brace frame configuration, and each of the residential floors is 12 feet in height, with the parking garage underneath 10 feet to the top of the footing. Shown here is the architectural layout that was developed for the apartment complex. This is a typical layout for the first residential floor, as all the other floors are very similar in design. In blue are all the bedrooms for the different types of units, and shown in red at each corner of the building are means of egress. Also included in the first floor is a housing office at the front, located directly next to the entrance lobby, and also laundry facilities for the residents, and also a utilities room. Shown in the southern end is the outdoor space that's provided for the apartment complex, and this will be discussed in depth later. Shown here is the underground parking garage layout. This was developed using the Meridian Township parking ordinance, and 45-degree angle parking was utilized to maximize the parking spaces within the structure. The shaded in regions are spots that are blocked off due to column obstruction. A total number of 67 spots were made available with a number of 4 handicap accessible spots. Once again, access for emergency exits are provided at all four corners, and shown in the green is available space for bike parking. The layout of the parking structure will be a circular path with allowing the cars to enter with one way and exit one way. This is a sample of one of the typical bedroom units. This is a 4-bedroom unit, and all the other bedroom units are very similar. All apartment units are equipped with a balcony, which would be composed of reinforced reinforced concrete slab. The only apartment unit that does not have the balcony is the 2-bedroom units. Like I said before, outdoor space provided for the apartment complex, which is very attractive, which it connects the apartment community, and it definitely is desirable for the Meridian Township marketability standpoint. Included is a pool, hot tub, and barbecue area, and also a direct connection to the expanded Interurban Pathway. It's going to be surrounded by trees to provide for privacy and also to reduce the noise pollution provided by the train to the southern end of the site. And like I said before, this definitely increases marketability of the apartment complex. The next step was to calculate all the loads that were to be acting on the building over its lifespan. These loads were calculated according to the AISC design manual. All the loads that were considered in this building were the dead loads, live loads, wind loads, snow loads, and roof live loads. Shown at the bottom is the load combinations that were determined also using the AISC design manual, and they were applied to the structural model for analysis. Once all the analysis, or the loads were calculated, it was thrown into a SAP 2000 model for structural analysis, and that was used to determine all the maximum moments and forces on each of the members. W-shaped members were selected for all the structural columns and beams, and a double angle section was determined for the bracing member. Shown here is kind of an outline of all the member design. A range of forces and moments were determined to reduce cost and to ensure no large over-engineering is done. Failure and serviceability limit states were considered, as shown in the charts to the right. All the sections were determined, and through member design analysis, all of them passed serviceability and failure limit states. And finally, a number of sustainable practices were considered throughout the design of the building. First of all, the majority of the structural steel will be acquired from a local steel manufacturer, Douglas Steel, which is located in Lansing, to reduce shipping costs. Also included in the steel acquisition, a lot of the steel from the manufacturers is largely recycled steel. Also, the orientation of the building is a sustainable design practice. The east-west orientation increases sun exposure, which helps reduce heating and lighting costs. Also included in the building design is the underground parking structure, which decreases the overall footprint of the building and allows for more green space throughout the site. And finally, deciduous trees was planted at the southern end of the site, which is also another sustainable design practice, as it allows for more sunlight during the winter and shields the sunlight during the summer. Now I'm going to hand it over to James for the transportation.
I'm James Steele, the transportation specialist for Tower Engineering. As transportation specialist, I had 5 primary goals. The first was to provide a safe and efficient site flow for our proposed site plan. Second was to avoid any negative impacts that may occur by the development on the existing traffic conditions. The third was to expand the existing interurban pathway, a mixed-use pathway located in Meridian Township, directly south of the site. The fourth was to promote walkability and bicycle access to the site to promote alternative transport. And the final goal was to promote green space and to prevent any negative effects on the local environment. All right, on this slide, I will go over the general site plan and the site flow. Here you can see, highlighted in green, is the main area for restaurant parking. In red are the 2 primary areas for above ground apartment parking. There's one north and one to the east of the apartment building. Directly in front of the apartment building, there are 12 temporary parking spots, and located beneath the apartment building is an underground parking structure. There's also 2 main aisleways on the site, one that runs east-west and one that runs north-south. and then 2 one-way aisleways. One that goes from the parking garage and temporary parking areas to this main aisleway, and the one that connects this main aisleway to the parking area for the apartment complex. In this slide, you can see the number of parking spaces per land use is broken down based on the square footage for each land use. The number of parking spaces was determined using the Meridian Township Parking Ordinance, and we come to a total of 548 permanent parking spaces on the site, which ends up being 560 when you add the temporary parking spaces located in front of the apartment complex. On the next several slides, I'll overview the site flow to each parking location. The parking location for the brewery and the restaurant is located directly in front of the building. It is easily accessible from both Marsh and Hazlitt Roads using these main aisleways. And as was spoken before, all truck traffic will be diverted behind the brewery where the turning radius has been made large enough to allow the trucks to perform a U-turn without having to back up. Here you can see the north apartment parking lot is also easily accessible from Marsh and Hazlitt Roads from the 2 main aisleways. The eastern parking lot is primarily meant for people coming from Marsh Road, as that is where it's easily accessible by. However, it is accessible from Hazlitt Road as well. The underground apartment complex, complex is located beneath the apartment and is just south of the above ground parking area. People can enter in from the west side. We have a circular flow through the underground structure, and then people can exit from the right. The temporary parking spaces are located directly in front of the building. There are 12 of them, and they are metered. So people can park there for up to an hour, and then they can move any groceries or larger items that they have from their vehicles into the apartment before moving to a more permanent space. My second goal as transportation specialist was to prevent any negative impacts that may occur on the local system due to the development. In order to prevent this, 4 traffic counts were conducted, 2 on Hazlitt Road and 2 on Marsh Road during the AM and PM peak hours, in order to get an accurate assessment of the current traffic conditions. Then the future traffic conditions for the site were generated using the ITE trip generation software, and both situations were analyzed using Synchro software. It was determined that no turning radiuses level of service will be affected by the development, other than these 2 left turn movements out of the west and middle drive. Currently, they're operating at a B during the AM peak hour, and after the projected development, they're predicted to operate at a level of service C, which is lower but is still acceptable. As you can see on this slide, currently the Marsh and Hazlitt Road, all turn movements are operating at a level A or B, and after the development, it is predicted that that should continue, which is just accurate. My third goal as transportation specialist was to provide an expansion to the existing interurban pathway, which is a mixed-use pathway. Mixed-use pathways are primarily meant for bicycle or walking traffic. No motor vehicles or horses are allowed on the site. Currently, the pathway extends all the way from Marsh Road, just south of the site, to the intersection of Bersham and Wild Blossom Court. It's approximately 1.8 miles, and it has a width of 10 feet with an unpaved shoulder of 1 to 3 feet on either side. Here you can see my proposed expansion to the interurban pathway highlighted in red. Currently, there is just an unpaved path that extends directly south of the site. It used to be Raby Road, and there's currently a few abandoned houses on it. It is not paved, and it has heavy rutting from vehicle tires. So that will be completely torn out and replaced with this paved pathway, which follows the same specifications as the existing interurban pathway. It'll be 10 feet wide with a 3-foot shoulder on either side. Additionally, the shoulder will expand to 5 feet, and fencing will be installed on the west edge of the site and around the detention pond to provide safety from the edge of the hill and from the detention pond. My fourth goal as transportation specialist was to promote pedestrian and bicycle access to the site. In order to do that, we have an extensive sidewalk system located throughout the site. All the sidewalks are 6 feet wide. Additionally, we have biking parking located at the organic grocery store, the brewery and the restaurant, and the apartment building. And currently, the closest bus stops to the site are located just north of the Hazlitt and Marsh intersection. There are routes 22 and 23, so people can easily access Meridian Mall. However, we have been working with CATA to get bus stops placed directly east of the site, just east of the site for Route 22 and just across Marsh Road for Route 23. On this slide, you can see all these expansions that are going to be added. In red is the entire sidewalk system for the site. In blue, you can see the bike parking locations located by the restaurant, the organic grocery, and then the apartment complex. Each parking location is expected to have around 20 bike parking spots. And then here on the east edge of the site, you can see the Route 22 stop and the Route 23 stop. And my final goal as transportation specialist was to promote green space and prevent negative impacts on the local environment. In order to do this, we have been really pushing for alternative transport to the site, such as bicycle and pedestrian access. And we've been attempting to design around the existing green space, such as the wetlands located to the west of the site, and by implementing 2 new green areas, such as the patio location located to the south of the apartment, and this small picnic area that'll be located at the 3-way intersection for the interurban pathway. And now I'll hand it off to Adam, our payment specialist.
Thank you. As James said, I'm Adam. I was designing the payments for the site. To properly design the pavements, first I had to collect data on the existing conditions of the pavement to determine if any of the pavement can actually be reused in the project itself. Several environmental factors were taken into consideration. The frost depth for the site to determine if any aggregate needed to be replaced to prevent against frost heaving, the ambient air temperature to select the proper binder for any asphalt paving, and working with Stefan, our geotechnical specialist, we determined the subgrade modulus for this existing soil on site. Working with James, we determined the induced traffic loading on the site to determine how much damage the traffic will do to the pavement. All designs were done on a 20-year design period to put them on even level. New pavement designs and different alternatives were designed. I'll go through this briefly. And my final recommendations was selected based on a life cycle cost analysis and the most cost-effective design.